Okay, last proof in the chapter is McCamey problem number 1. It's the converse of the one that was problem number 1 in Lambkin. Prove that if two chords are equidistant from the center of the circle, then they are congruent. Right? So our diagram is the same as it was in the last problem, where we have center O, two chords A, B, and C, D. And what we're given this time is that they are equidistant. So I'm going to draw the distance again. That is this. We drop a perp from O to chord AB, and we drop a perp from O to CD. This, and again, we're going to call these E and F, just like we did in the last problem. And so we know that these distances are the same. All right, that's what we know when it says that the chords are equidistant from the center of the circle. All right, so we know we have circle O with chords A, B, and C, D, each equidistant from O, and that's the given. Okay, so then our next statement would be to say, well then OE and OF are equal. And that is definition of equidistant. All right, statement 3 would say that OE is congruent to EF. Again, why do we have to do this? Hold on first. It's definition of congruent segments. Why do we have to do this? Again, think back to the last problem. The last problem we had to prove that these two triangles, and again, we're going to follow the same process essentially, these two triangles were congruent. And so we need to be getting ready for that, where we've got segments that are congruent, not just equal to in length to each other. All right, now I'm going to add a step here, just as we've been doing. We're going to say draw OA, OB, OC, and OD. Reason, 2 points, determine a line. Whoops. Forgot the M there. Determine a line. So let's draw those in. Oh, Abby just got a text. All right, let's draw those in there. And then what we're going to say, as we've been saying in each of these, is that OA, OB, OC, and OD are congruent. And the reason is because all radii are congruent. Oh my goodness. Okay, so I'm going to mark each of these like this. Okay, then we've got statement 6. First we have to, so hopefully you're realizing here we've got a hypotenuse in each of these triangles. We've got a leg in each of these triangles. So we could use, actually, we don't even know that, we have not established yet that that's a hypotenuse. So next thing we're going to have to do is establish that these are right angles so that this becomes a right triangle so that we can use hypotenuse leg. So that's our next step right there, is to say that DE is perpendicular to OE. All right. That's establishing this angle right there. DE and OE are perpendicular to each other. We'll say the same thing. Let's see. DE is perpendicular to CD. I think he made a mistake here. DE is perpendicular to CD. That's not right. I think it should say OE. Yeah. And then OF and AB. All right, so then let's change this not to DE, but DC. and OE are perpendicular. That'll make it a little bit easier instead of doing 4 times this and this and then this and this. So we'll just do it with 1. So then we'll also say that AB is perpendicular to OF, right? And the reason for that comes from, this is just the definition of the distance of a point to a line. And then number 7 is going to say, then these 4 triangles in here are all right triangles. So triangle AFO, triangle BFO, triangle DEO, and triangle CEO are all right. And then the reason is definition of perpendicular. Okay, then number 8 is going to say that triangle AFO is congruent to triangle BFO, which is congruent to triangle, I'm just going to copy these down, triangle DEO is congruent to triangle CEO. And the reason is, oh my goodness, sorry, that's Abby again. This is HL. And then number 9 is that we can say that AF is congruent to BF, which is congruent to ED, which is congruent to CE, and that is all CPCTC. All right, so we've got these 4 triangles that are congruent. Therefore, this side right here on each of the triangles ends up being congruent. Let me mark that with 3 lines, 3 lines, 3 lines, 3 lines right here. And now comes the annoying just adding everything together. So we're going to say for 10, first we're going to say all of them are equal in length. AF equals BF equals ED equals CE. That's just definition of congruent segments. And then we're going to say that AF plus BF is equal to AB, and CE plus ED is equal to DF, CD. And that's just definition of between. And step 12, this is getting long and I'm going to have to fold my paper because I'm running out of room here. All right, step number 12. Now that we've got those statements there because of betweenness, we're just going to do a whole bunch of that algebra again and just say that AB and CD are equal. And then finally for 13, AB is congruent to CD. And that is definition of congruent segments. All right, hope that helped. Those were 2 really long proofs. They were a lot more steps than we're used to. So hopefully you could follow the steps along, even if you could not necessarily think of them on your own. Okay, bye.